Day 4, problem 1. A person is 5.5 feet tall and casts a 12-foot shadow. At the same time, a nearby tree casts an 84-foot shadow. Sketch a diagram. So for this, we need to indicate where the ground is, and then we have a person, and so our little stick figure is our person, and then there's a nearby tree. And so something like this could be the tree. Now if the sun is up here to the right so that the sunbeams are coming down this way through the sky, then the shadows will lie to the left side of the objects, right? So the sunbeam comes down like this, and then this part of the ground is going to be darker because the tree is blocking the sunbeams. So what we have here are some right triangle shapes. So there's a right triangle located where the person is, and there's a similar shaped right triangle located where the tree is. Now we can label some measurements on here. We know that the person is 5.5 feet tall, and so this side is 5.5 feet. And the person's shadow is 12 feet long. So I should have drawn this so it actually visually looks about twice as much as this. I didn't do that, and that's okay. The more important thing, though, is that we get the similar shaped triangles. Now the shadow for the tree is 84 feet. And we don't know how tall the tree is, so that's where we label X. So there's the diagram. Now question B. Make a proportion from the similar right triangles. So proportion is an equation where you're comparing things on the left side of the equation and comparing things on the right side of the equation, and these comparisons are equal to each other. And so how this works is we can compare the height of the person to her shadow. So 5.5 can be compared to 12. And then in terms of when looking at the tree, let's make the same comparison, the height of the tree compared to its shadow. And the whole idea here is that we're able to measure tall objects like trees or buildings or towers or whatever without directly measuring them with a tool. You know, we don't have to climb up to the top of the tree and actually stretch out a tape measure to measure this. We can measure this indirectly by using concepts from geometry class, in particular here, similar triangles. Now to solve this equation, there's a variety of ways, but one thing to always try on a proportion is to look for patterns. Sometimes there's patterns that you can notice between this number to this number, or a pattern from this number to this number. And this time, that's where I noticed the pattern. In the denominators, from 12 to 84, 12 times 7 is 84. What this means is the tree's shadow is 7 times longer than the person's shadow. We can use that pattern to find the height of the tree. If the tree's shadow is 7 times longer than the person's shadow, that means the tree's height is 7 times higher than the person's height. If we go 5.5 times 7, that'll get us the answer for X. So let's do that. 5.5 multiplied by 7. Let's see what we get. 5 times 7 is 35, carry 3. 5 times 7 is 35, plus 3 is 38, and the decimal point needs to go right there, 38.5. So our tree is 38.5 feet tall, measured indirectly because of things that we know from geometry class in high school. Now day 4, problem 2. We have 4 arithmetic questions. Question A, -1 times -10. Negative times negative is positive. 1 times 10 is 10. Question B, 96 divided by -6. Positive divided by negative is negative, and now 96 divided by 6. Let's see what that is. 6 divides into 96. 6 divides into 9 once. 1 times 6 is 6. Now subtract. Bring the next digit down, creating 36. And 6 divides into 36 6 times exactly. We get a 16. And so our answer is negative 16. Question C, subtracting fractions. To subtract fractions, we have to have the same denominator. Right now they don't have the same denominator, but that's okay. We can fix that. Let's multiply the first fraction by 3 over 3. That will change it to 6 over 21. Let's multiply the second fraction by 7 over 7. That will change it to 14 over 21. So we have 6 over 21 subtract 14 over 21. We're going to have a denominator of 21. We just need to be careful in the numerator to recognize 6 subtract 14 is negative 8. 14 subtract 6 would be 8, but 6 subtract 14 makes negative 8. Now question D. 18 over 20 divide by 6 over 12. One way to divide fractions is to change it to multiplication by multiplying by the reciprocal of that. So the reciprocal of 6 over 12 is 12 over 6. Now we have a multiplication of fractions problem. If we multiply this right now, 18 times 12, we get a pretty large number in the numerator. It's not even one that I've memorized from my times table. I don't know what 18 times 12 is. So if there's any reducing, or some people call it cross-canceling, that we can do right now, that's going to make these numbers smaller and easier to multiply together. So let's look for reducing right now. Some people call this cross-canceling. 18 and 6 reduces. 18 divided by 6 leaves 3, and 6 divided by 6 leaves 1. 12 and 20 reduces. 12 and 20 both divide by 4. 12 divided by 4 leaves 3, and 20 divided by 4 leaves 5. This reducing ahead of time is going to make getting the final answer a lot easier. 3 times 3 is 9. 5 times 1 is 5. Final answer, 9/5.